Hi guys, today in this video we will discuss about a very important and significant topic of NLM which plays an important role in almost all the chapters of mechanics as well as in physics. So this topic is free body diagram, and in this topic we will discuss about the basic of drawing the forces on an object, which means if some force or some set of force are acting on an object, then we have to imagine that object isolated from the surroundings, and we have to draw all the forces on it in according to their directions which are being applied on that object. So a free body diagram consists of a diagrammatic representation of a single body or a subsystem of bodies isolated from its surrounding, showing all of the forces acting on it. I know this statement is a bit confusing, so I'll illustrate the statement. So for the illustrations, let me take a situation in which a block of mass m is being kept on earth, and this is the situation which I'm talking about. So this block is being kept on earth and it is at rest, obviously. So if I draw the free body diagram of the block, so I'll isolate the block from the system and the surroundings, and I'll mark all the forces which are acting on the block. Now first of all, I know that a force mg is acting on the block downwards, and I'm writing the name in the bracket of that body which is applying this force on this block. So mg is a force which is applied by the earth on the block, so I'm writing earth in the bracket. Now if mg is acting on this block but block is at rest, so it is due to the fact that a normal reaction is acting on the block in upward direction, and this normal reaction is also being applied by this earth. But there is a difference, that it is a field force. mg is a field force. I'm writing here field force, and this is a contact force. In fact, I can say that if this block was not touching the surface of the earth, then this normal reaction would not have been acting on the block. But I can say that even though the block is not touching the surface of the earth, this mg is being acting on the block due to earth, because it is a field force. And now if I draw the free body diagram, this is the free body diagram of this block, and if I draw the free body diagram in case 2, this one, so I can see that if this is earth, then on that 50 kg block, this one, a force of 50g is 500 Newton, assuming the fact that I'm taking acceleration due to gravity to be 10, or for simplification I can write 50g. G is acceleration due to gravity. This is mg, and this force is being applied by earth, and this is a field force, and this block is still in a state of rest, and it is also due to the fact that this 50 kg block is being applied by a normal reaction N1 by that 1 kg block. So I'm writing that 1 kg block in the bracket, which means that this normal reaction is being applied by that 1 kg block on 50 kg block. So this is the free body diagram of that block B. And now if I draw the free body diagram of block A, so for block A, 1 kg of its mass, and mg is acting downwards, which is 1g. 1g is mg, and it is being applied by earth. So another force. See, now we have to we cannot ignore the fact that 50 kg block is experiencing a normal reaction force N1 due to 1 kg in upward direction. So that 50 kg block will also apply the same amount of force on 1 kg block in downward direction, as each and every action has equal and opposite reaction. So this N1 will also act in downward direction on 1 kg block. Now 1 kg block is still in rest, and it is also due to the fact that on 1 kg block a normal reaction force N2 is acting in upward direction, and this is due to the earth contact. And this N1 is acting due to 50 kg block. Okay, so this is the free body diagram of block A. Now I hope you must have learned something from this illustrations, and I'm taking another one here in the diagram. So in this situation I can see that there is a ball in first case, this one. There is a ball which is being kept as shown in the figure, and none other external force is being applied on the ball. So if you draw a free body diagram of this ball, we'll see that mg is acting downwards, and this force is again due to earth. Normal reaction is pointing towards upside. This is again due to earth contact. Okay, now this see, the thing we can see that this ball is not pushing this wall. This ball is not pushing this wall, this one. There is no pushing force by the ball on the wall. So although ball and wall are in contact with each other, but there will be no normal reaction acting between them. There will be no normal reaction acting between ball and wall. So this is the complete free body diagram of this ball, and here is an important fact which I am pointing out, is the fact that although this ball is touching the wall, but this ball is not pushing the wall, so there is no normal reaction acting between ball and wall. This is very important aspect of normal reactions, that it does not act only when the objects are in contact. In fact, it will act when they are being pushed against each other. Okay, now in this second situation, we can see that the ball A and B are situated like that, and a force of MAG is acting on the ball A downwards due to earth. And again this ball B, as it is restricted by the ball A to go down, so ball B will be pushing ball A normally like that. We have to consider a fact that normal reaction always acts perpendicularly to the contacts. So if the contact is like that, so normal reaction will be acting like that, perpendicular to the contact. So we will again draw a normal reaction which is NAB. Let me name it NAB, normal reaction force on A due to B. So I can write here due to block B. Now another force is acting on block on ball A, which is in upward direction. This is normal reaction due to earth. earth contact. I'm assuming this bottom surface in all the cases to be earth contact. So this is the 3-force free body diagram of ball A, and similarly if I draw the free body diagram of ball B, then there will be a MBG, let me say it MBG, and it is acting on ball B due to earth, and there is a force of normal reaction due to this wall. This wall would be pushing that ball B towards that side, because this ball is pushing the wall towards right side. So there will be a normal reaction force towards left side due to wall, and let me name it as N1. N1 is due to wall. Okay, now I missed out something in A, that in free body diagram of A there will be a normal reaction N, let's suppose N1, and this is N2 due to wall. This wall will be also pushing this ball A. I missed that one. So let me correct myself, that there will be a 4 force, A, 1, 2, 3 and 4 acting on this ball A. So now in again coming to the ball B, there is MBG which is acting downwards. There is normal reaction N1 which is due to the wall, and there will be a normal reaction NAB which is acting in the just opposite direction to the normal reaction of A. So you can see that ball B applies a normal reaction on A in that direction, and in the reply to that action, A will also apply the normal reaction, same amount of normal reaction on B in opposite direction, pointing towards upside. So this is the basic concept of free body diagrams, and before attempting any numerical of mechanics, it is very necessary, and it makes the problem simpler to draw the free body diagram. And the steps to draw the free body diagram is, firstly you have to isolate that object from all the surroundings, and you have to draw the all possible forces acting on that object with their appropriate directions. That will be the free body diagram of that object. So guys, I hope this video would help you in mechanics, in solving out the complex mechanics problems, and I'll be coming up with more important topics of mechanics. Thank you.